So welcome back to the second part of creating chemical compounds. And just as I was explaining in the previous video, remember, chemical compounds in inorganic chemistry are created by having a positive part, which is always located on the left of the formula, and a negative part, which is always located on the right-hand side. And as I said, cations can be metals, hydrogen, nonmetals, which include metalloids with a positive charge, or anions can be nonmetals, metalloids, hydrogen, oxygen, hydroxide, and oxyanions with a negative charge. Now, to make it clear again, let's imagine that a single compound, such as we saw in the other video, is sodium chloride. So in order for sodium chloride to come together, we can try and kind of see it like if it was a jigsaw puzzle, where one part is a positive part, and again, the other part is the negative part. And once they're together, they create a single compound. So in this case, chlorine and sodium, once again, sodium is positive, chlorine is -1. We don't write the 1, sometimes we do, but it's not necessary. And when they come together, they create this electrostable compound, once again, NaCl. Okay? Now, when we speak about valence, which is the charge of the different elements, remember, group 1 metals such as sodium, such as lithium, such as potassium, are always going to have one electron to give, right? So maybe we can represent them as these jigsaw puzzle pieces. So we have, for example, sodium and potassium, and we have lithium, for example, as well. And what they want to do is they want to give away this electron, so that's why they're going to eventually become +1. So naturally, their best match are elements or anions that are -1, such as halogens, which want to receive 1 electron to be complete. And some examples of halogens are chlorine, bromine, iodine, or we could also have some sort of polyatomic ion, such as hydroxide, which is also -1. And then when we put these together, these naturally need 1 and 1. And again, just as I showed in the previous video, if I take sodium, which is +1, and I take chlorine, which is -1, these numbers crisscross. And when we crisscross them, we invert the little numbers. Remember, 1 is never written, so we end up with NaCl. So the same thing's going to happen with all these pieces, but what we can't put together is we can't put together 2 anions, we can't put together 2 cations. What we can do is 1 piece of this, 1 piece of this. So another example, potassium +1, hydroxide -1. So then when we do the crisscross, K1OH, all of it 1, it's going to turn into KOH, potassium hydroxide. Now, there are elements that want to give away 2 electrons. For example, group 2 metals, like let's say magnesium. So we can draw this as this other piece. So magnesium is +2. And if you see, how is this going to work? Same thing. Let's try to mix magnesium with another element that's also wants to receive 2 electrons. So the example would be oxygen, which is -2. So these are going to fit perfectly together, right? And we can prove this mathematically again. Mg is +2, O is -2. When we do the crisscross, Mg2O2. But how many pieces do we actually need of each? Only 1. So our final formula is going to be MgO, and we would have this, for example. Mg, which matches perfectly with O together in the same puzzle piece. Now, taking the same example, what happens when we mix magnesium, which is +2, with chlorine, which is -1? When we do the crisscross, once again, this comes down here, magnesium 1, this comes down here, the 2, and we get chlorine 2. So we eliminate this 1 to simplify, and we get magnesium chloride. Okay? And if we try to do it graphically, remember, magnesium wants to give away 2 of its electrons that I'm representing here with these little 2 humps in the puzzle piece. +2. And chlorine is a smaller piece, which is like this, and it can only receive 1. So how many pieces of chlorine are we going to need to complete the puzzle? We're going to need 2, right? So when we draw our final representation, because each one of these is -1, what are we going to get? Effectively, +2 cancels out with -2, and we might get something like this. Again, this is a graphical representation which should in theory make it easier for you to understand, but we also have the mathematical explanation up here, okay? So in this case, let's mix something else together. Let's say we have calcium, which is +2, which is my positive part or my cation, and then as an anion, we're going to choose phosphorus. Phosphorus is -3. So again, we do the crisscross. And once we do the crisscross, we get Ca3, P2, and this is our final formula because we cannot reduce it any further, okay? Another quick example, let's choose, for example, chromium. Chromium can have a valence of +3, and let's choose, for example, nitrogen, which is also -3. So when we do the crisscross, what's going to happen? Chromium gets a 3, nitrogen gets a 3, and since they're both 3, that means that we're going to reduce and we only need one piece of the puzzle. And following the analogy I showed you, the cation is going to have 3 little humps, and the anion is going to have 3 pegs that it can fit into, 3 spaces for the pegs. This is nitrogen -3, and this is chromium, which is +3, and they match perfectly together to create one single compound. Okay, so this is for the mixing of elements.